the right tool at the right time, a first-of-its-kind facility that addresses the challenges of large-scale integration of clean energy technologies into the energy systems that power the nation.
It'll spawn new areas of research, it'll spawn new areas of inquiry, and I think for the most part, we'll see system science in a new way that we've never seen before.
The U.S. Department of Energy's Energy Systems Integration Facility, or ESIF, at the National Renewable Energy Laboratory is the proving ground for green energy.
One of the unique capabilities that we have at this particular facility is that we'll be able to test at the megawatt scale.
It is a facility designed to look at the integration of all variety of power energy production capabilities with the demand side of the grid, vehicle technologies, buildings, and so forth.
The ESIF is an absolutely fantastic facility to add to our energy community and the ability for us to do research.
ESIF is a state-of-the-art resource to advance clean energy technologies and practices, to research, develop, and validate at each phase of innovation.
There's not really been a place in the past to look at things and sort of plug it in and see if it works. And I think that's one of the unique capabilities that ESIF offers and something that I think will provide a lot of value to our society.
That's a very important aspect of this particular user facility, is to help those that will adopt technologies actually experience the technology before they take the risk of an investment.
The array of equipment and expertise at ESIF are available to entrepreneurs, utilities, industry, and academic partners to evaluate technologies and more quickly move them toward market adoption.
It brings together an entire community all focused on this new area of science and engineering, if you will, systems integration, to create a knowledge base that's open and available to that community to be able to help us move forward at a faster pace.
The issue is now the challenge of integration, and that brings us here to ESIF.
As renewables become greater contributors, utilities are working with NREL to achieve their clean energy goals and ensure the infrastructure is ready and reliable.
I'm really excited about the next chapter in NREL's progress and the integration of distributed generation resources, et cetera. It's a challenge. I also view it as an opportunity. We need to do it right. We need to be pragmatic about it. And I think we can do that, and I think we can really unlock the power of the future beginning today.
It's going to help us transform the energy system to the one that we need in 2030.
We're open for business. We've got a brand new facility, once in a lifetime opportunity to come in and begin using a capability that looks at integration of energy systems to be able to advance industry within this country, advance utilities, advance automobile manufacturing, just advance all aspects of our energy system in the world.
ESIF is about energy systems integration. It's analyzing and optimizing how technologies interact with one another.
What we do in this laboratory is actually take these individual technologies, characterize their performance and how they impact the actual grid, and then work with utilities to help them understand what these can do.
We are making the world think about how to integrate all these different components to have a greener, cleaner future, a sustainable future that doesn't depend on our traditional sources for electricity.
This facility is the intersection of renewable energy technologies and the systems to move that energy to our buildings and vehicles. It's addressing the challenges in increasing energy efficiency and renewable energy, offsetting the variable nature of sources such as wind and solar, and improving our infrastructure.
Power Systems Integration Laboratory, or PSEL, is our largest laboratory, and it's sort of the workhorse for the electrical systems laboratories.
The Power Systems Integration Laboratory at ESIF allows for real-time, full-power electrical performance and safety simulations. The circuit of AC-DC bus bars connects energy sources from thermal energy to transportation fuels and electricity to provide insights into impact and functionality.
So that we can plug and play real-world technology and look at the impacts on the grid, for instance. Integrating that together is a major SCADA. It's a management system and facility.
We're standing in the control room right adjacent to the Power Systems Integration Laboratory. And what's going on behind us, you see display from our SCADA system. SCADA is the supervisory control and data acquisition system.
The SCADA system monitors and controls ESIF research and gathers real-time data for collaboration and visualization.
We're in our data immersion facility where we are able to display in 3D format all variety of data around the energy system. This particular display that you're looking at is organic PV materials.
This information brings energy management to life in a virtual environment for real-world analysis.
When you get large data sets like that, you simply cannot look at that data in a piece of paper and be able to really glean enough information out of it. So you get a facility like this where you can actually display the data in 2D and 3D formats, and you gain so much more insight.
We have a brand new high-performance computing data center, and the data center is built to house our HPC systems that support the breadth of the lab's mission.
The high-performance computing data center at ESIF is reimagining the once energy-hungry data centers of the past. It is one of the world's most energy-efficient data centers.
One of the things that makes our data center very efficient is we're using the liquid cooling, and liquids as a heat exchange medium are about 1,000 times more effective than air cooling. So a traditional data center, which is not as efficient, will use lots of fans.
And rather than exhausting heat from the computers, NREL is reusing it to warm the building, a more holistic approach.
From a data center perspective, it's a chips to bricks approach. So thinking about the component level liquid cooling within the servers, out to the racks, integrating this within a data center, and think broader into a more integrated campus.
In this laboratory, we look at the solar collectors.
Scientists at ESIF are studying ways to lower the costs of concentrating solar power systems, which can reliably provide dispatchable electric power whenever it's needed.
The advantage of this method is that it allows us to produce thermal energy storage. So when the sun's not shining, we can continue to generate steam and produce electricity.
ESIF's fuels and transportation labs are looking at accelerating development and deployment of hydrogen fuel cells and plug-in electric vehicles to lessen dependence on fossil fuels.
The ESIF allows high power to be integrated between different laboratories, including things like vehicles and large battery storage, as well as fuel cells that actually can convert hydrogen into electricity.
The ability to look across energy pathways, to be able to look at the trade-offs between electricity, thermal energy, and fuels is also a unique aspect.
Plug-in electric vehicles use electricity from the grid to store the energy on the vehicle. This facility can basically lower the risk by looking at what a high penetration of vehicles on the grid would do, and then provide mitigation strategies to make sure that they won't be a problem in the real marketplace.
Our goal here is to not just innovate, but to have impact at the end of the day.
The Energy Systems Integration Facility is the nation's newest asset for realizing our clean energy future. It brings together real-world experience in a laboratory environment at just the right time.
So as our whole energy system evolves in the future, we're going to have a much more complicated, much more diverse set of production and use capabilities. This facility will help industry, utilities, and the researchers understand what those interactions are.
ESIF is the toolbox for transforming our energy system, for research and development on a new scale to move renewable energy technologies to the market at greater speed. There is nothing like this in the world.
This facility allows us the opportunity to really be the center of research and new approaches to integrating renewable energy and distributed resources onto the next generation smart grid.